Hello everyone, I am Divya, your maths facilitator. So today let us learn a very new topic called tangents and secants to a circle, which is our very important chapter and very small chapter of our class 10. Okay, so let's begin the session. So today we shall cover exercise 9.1 also. Before doing exercise 9.1 we have to learn few concepts. So let's firstly focus on the simple concepts which we already know. Now tell me, what is a circle? The first definition you will have to know is a circle. Okay, because we are going to talk about tangents and secants to a circle. So I need to know what is a circle. So from a fixed point, if I take a fixed distance, okay, from a fixed point, say O, if I am taking a fixed distance, if I am measuring a fixed distance, okay, say R, and if I am marking all those points which are at a fixed distance from this point O, so I will get so many points around this point O which are at a fixed distance OR. Okay, so I am getting so many points around the center point O which are at fixed distance OR. So I can say OR is my radius. Okay, it is my radius. The fixed distance is called as radius, and the center of the point, the fixed point which you have chosen, is called the center. Okay, so the fixed point is called center and the fixed distance which you have taken is called radius of the circle. Okay, and the collection of all those points which are at a fixed distance from a fixed point are called, the collection of all these points are called circle. Okay, so now as you have seen, what is radius? Radius is nothing but it is a fixed distance. Okay, it is a fixed distance, or in other words I can say radius is nothing but the distance between. Okay, it is the distance between. You can make a note of all these important points because these may look very small, but if these are not clear you will not be able to proceed further. Okay, so distance between center and any point on circle. Okay, so I can say radius is nothing but a fixed distance, or I can say it is the distance between center and any point on the circle. Okay, for example, if I am taking one more point on the circle, say this point, so if I just find the distance between the point, so this also will be equal to radius. Okay, because all these points are at a fixed distance, at the same distance, whatever is this distance, all the other points are also of the same distance. So radius is nothing but distance between the center and any point on the circle. You can take any point on the circle. Okay, so that is nothing but radius. Now what is the meaning of diameter? Diameter is nothing but any line segment. Okay, so if this is a circle, if I take any line segment which is joining two points on a circle, for example this is one point I am taking and this is the other point, and if I want to join these 2 points on the circle and I want to pass it through the center. Okay, so 1 second, it is a line segment, so it has to be a straight line. Okay, so we are touching 2 points on a circle and it is passing through the center. You are touching 2 points on the circle and it is passing through the center. So such a line segment is called diameter. Okay, so I can say it is passing through center. It is a line segment which passes through center and touches 2 points on a circle. Okay, and it will be joining or touching 2 points on a circle. Okay, so joining 2 points on a circle, passing through center, that is called diameter. And you can see from this part to this part, center to any point on circle is radius, center to any point on circle is radius. So the total is actually diameter. So can I say diameter is 2 times radius? Radius plus radius is 2 times radius. So this is your diameter. So this is your radius, this is your diameter. Now coming to the most important points where students get confused. Can anyone tell me what is chord? What is chord of a circle? See, we spoke about diameter. Chord is also the same thing. Now if this is a circle, if I have any line segment joining any 2 points on the circle, now this line segment is joining any 2 points on the circle, this is called as chord. Okay, so I can say it's a line segment. Understand the word I am using, it's a line segment. Okay, so line segment has 2 end points. What are the 2 end points? The 2 end points are the points on the circle here. Okay, line segment joining, it's a line segment joining any 2 points on the circle. Any 2 points on the circle. Now have a look at the diameter definition. We said the diameter passes through center and joins, okay, and it joins any 2 points on the circle. Okay, so diameter is also joining any 2 points on the circle. It is also a line segment. It is joining any 2 points on the circle. Can I say diameter is also a chord? See, diameter is also a chord, and on a circle you can have number of chords. Okay, you can have so many chords in this way, so many chords in this way also. And suppose if I take this is the center O of the circle, there is one such chord which joins 2 points on a circle and passes through the center. What is this chord called then? It is called as simple diameter, isn't it? So we can say diameter is also a chord. So now I'll tell you a very important point. Understand this. All chords are not diameters, but all diameters are chords. Is this true or false? Quickly let me know in the chat box now. All chords are not diameters, but all diameters are chords. See. Answer? Did everyone answer now? Okay. So if I take all the chords, now if I take this chord is not diameter. This chord is not diameter. This chord is a diameter. So all chords need not be diameters, but all the diameters, if you consider, take any diameter. So all these diameters will definitely be chords, because they are line segments joining 2 points on a circle. The additional condition is they are passing through center. So all diameters are chords, but not all chords are diameters. And one more very important point is, so diameter is the longest chord. Okay, and one more very important point is diameter is the longest chord. So you may get all these points for your objective type or a 1 marker question. So they are important. Diameter is the longest chord. You can say it is the longest of all the chords of a circle. Okay, and can anyone tell me how many points does a circle has? On a circle, how many points do I have? Okay, on a circle, how many points do I have? I'll have infinite points on a circle. Okay, on a plane you have infinite points, and from those infinite points, so if I'm counting all these points, point is very small, isn't it? Here we are marking it this way, but it is actually very small, very minute. So if I see there are so many points which are at equidistant from the center point, so there are actually infinite points on a circle. Okay, so here we are marking it in this way in the form of dots, but point is actually very small. You have learnt in your class 9 elements of geometry also, isn't it? So chalo, so we have learnt about chord. Now the next important concept you will have to learn is secant. Secant and tangent. I have learnt about chord. What is chord? Chord is a line segment joining any 2 points on a circle. Now what is secant? Secant is a line. Okay, it is a line cutting the circle at 2 points. You can see secant is cutting the circle at 2 points. Line cutting the circle at how many points? At 2 points. Clear this definition? It is a line. You have to understand secant is a line. It is cutting the circle at how many points? 2 points. Right. Okay. Whereas chord is actually a line segment which is only joining the 2 points. Secant is cutting the circle into 2 parts, you can see. Okay. And when I am taking a chord, okay, suppose if I take a chord, suppose if this is a chord, this is a circle, this is a chord. Now the chord is dividing the circle into 2 parts. What are the 2 parts? Here I can see this is one part and this is the other part. Okay, each part is called a segment. What is it called? it is called a segment, and the major part is called major segment, small part is called minor segment. Okay, each part is called as a segment. Clear till here? Oh, so this is what I was drawing. This is the chord, this is the chord, okay, and this is one part, this is the other part, right? So I hope you understand. This is one part, this is the other part. The chord is cutting the circle into two parts, and I have just shaded the smaller part. The smaller part is called minor segment, and the larger part is called the major segment. So can you define segment? Segment is the area, okay, this is the area enclosed between whom? Enclosed between, this is between the chord and the arc, okay, the chord and the arc. I hope you know what is arc. Arc is a part of the circle. Suppose this is circle, if I take a part of the circle, this is called arc, and this is called minor arc because it is small, and this is called major arc. Okay, so the area enclosed between the chord and the arc is called segment, and if it is the minor arc, it is called minor segment. If it is the major arc, this area is called major segment. Now what is the meaning of sector? Now suppose if this is a circle, I have my center O, and these are the two radii of the circle I am taking. Okay, so center to any point on circle, what is this? This is radius. Center to any point on circle, this is also radius. Let me take it as A, B. OA is radius, OB is radius, AB is the arc. Okay, so now this area is called what? It is called sector. I can say the area enclosed between two radii. Okay, I have two radii here, two radii and arc, and its corresponding arc is called a sector, and this is small, so this is called minor segment, and the outer region, this is called as major sector. Clear? Okay, now let's talk about tangent. So with this we have completed all the topics, all the important definitions related to circle, but there is one very important definition which is tangent. So let's talk about tangent. Let me clear the board a little, or let me try to explain you here itself. So let us talk about tangent. So suppose I have a circle and I have a line which is just touching the circle at a single point. There is a line which is touching the circle at a single point. Such line is called tangent. Okay, so line touching the circle at a single point is called tangent. So let us understand the differences between whatever we have learned today. Okay, see here. So radius is the distance between center and any point of circle. Diameter is the line joining two points on circle and passing through center. Chord is a line segment. Okay, diameter is also the line segment. Chord is also the line segment joining any two points on the circle, and all diameters are chords, and diameter is the longest chord, but not all chords are diameters. We have learnt all these points. Now secant is similar to chord. Okay, secant is same like chord. It is also touching two points. This is also touching 2 points in the circle, but it is extending. Okay, it is a line. The only difference is chord is a line segment, it is stopping there. Secant is a line, it is extending. So if I extend the chord actually, okay, so if this is a circle, this is a chord. If I am extending the chord, so it will become a secant actually. Okay, so the line segment, if we are extending, it becomes a secant. So secant cuts the circle at 2 points. Okay, and it is a line. Now tangent is also a line. Tangent is also a line, but it will touch the circle at a single point. So understand, secant and tangent are actually lines. Secant and tangent are actually lines. They are, secant is cutting at 2 points, tangent is cutting at only a single point. Chord is a line segment. Clear? So let's proceed to the next concept now. Okay, so now since you have learned what is a tangent, what is a secant, right? So let us proceed to the next concept. Tell me, if I draw a circle, now this is a plane. On this plane surface, I am drawing a circle. Now this circle, okay, now this circle is divided into how many parts? This circle is dividing the plane into how many parts? You can see the circle is dividing the plane into 3 parts. You have learnt in your lower classes also. This is the first part. Inside the circle is one part, outside the circle is one part, and on the circle is one part. So 3 parts it is dividing. So let me consider 3 points, okay, with respect to the circle. That is, 1 point I'll consider inside the circle, 1 point I'll consider outside, 1 point I'll consider on the circle. So for example, the first case I am considering inside the circle, second case I'll consider on the circle, third case I'll consider outside the circle. Okay, so see here, suppose I have a circle, I am considering a point inside the circle. Say this is a point inside the circle. Now tell me people very quickly, how many tangents can I draw from this point? How many tangents can I draw from this point which is inside the circle? Tell me very quickly. If I draw any line, tangent is nothing but a line. So if I am drawing any line from this point which is inside the circle, definitely that line will cut the circle in 2 points. You can draw any line. Okay, you can try in any way, that line will cut the circle in 2 points. So the conclusion is you can draw no tangent. Okay, the conclusion is you can draw no tangent from a point. You can draw no tangent from a point inside the circle. Okay, next case, suppose if I take this is a circle and if I want to draw a tangent from this point on the circle, how many tangents can I draw? I can actually draw only one point, only one tangent from this particular point. If I draw any other line, that will actually become a secant. It will cut the circle in 2 points. This is one point, this is the other point. Take any other line. So there will be only one line which touches the circle at a point. So that particular line only we are calling it as tangent. So from a point on the circle, I can draw only one tangent. Now tell me, how many tangents can I draw from a point external? Suppose this is the external point, say R. From this external point, how many tangents can I draw? How many tangents can I draw? Yes. From the external point R, how many tangents can I draw? I can draw from this point, I can draw one tangent this way. Okay, one tangent this way and one tangent this way I can draw. Okay, now you may ask, ma'am, tangent is a line. You said it is a line, but this is a ray. Actually, this is a line which you can draw. Okay, but from the external point. Okay, so see, this is one line and this is the other line. This is a tangent, this is a tangent. Both are passing through the same external point R. Okay, so ideally we do not draw this. We usually denote it this way. Okay, so this is one tangent, this is the other tangent touching the circle at single point. If you take any other line, okay, it will not touch the circle at a single point, it will cut the circle at 2 points. Any other line you can take. Clear? So outside the circle, how many tangents you will have? 2 tangents. Inside the circle, how many tangents you will have? 0 tangents, no tangent. And on the circle, how many tangents do I have? 1 tangent. Let me know how many tangents can I draw on a circle. Okay, how many tangents can I draw on a circle? Now just now I told you, on the circle, if I take a point, I can draw only one tangent from that particular point. Now my question is, how many tangents can I draw to a circle? Tell me the number of tangents I can draw to a circle. So we have learnt on a circle I'll have how many points? I'll have infinite points. How many points are there? I'll have infinite points. We have just now learned that from one single point I can draw one tangent. One single point I can draw one tangent. So from each of these single points I can draw one tangent. How many points are there? Such points? Infinite points. So how many tangents can I draw? Infinite tangents I can draw. Are you understanding this point? Okay, suppose from this point I can draw one tangent. If I take one more point here, from this I can draw one tangent. If I take one point here, I can draw one tangent. So which means from every point on the circle I can draw one tangent. And how many points are there? Infinite points are there on the circle. So I can draw infinite tangents to a circle. From a single point I can draw only one tangent. Is this very clear? And one more very important case is, suppose I have a circle. I have a diameter. Okay, So from this is the end point of the diameter, this is also the end point of the diameter. So from one end point of the diameter, if I am drawing a tangent, from this end point, if I am drawing a tangent, okay. So these two tangents are parallel tangents. How are these two tangents? They will be parallel tangents. So the tangents drawn from the end points of the diameter are parallel to each other. And now tell me, suppose if I have a circle, how many parallel tangents can I have at a time? Okay, if I have one tangent, if I take one tangent, to this tangent I can draw only one parallel tangent. Okay, to a given tangent, if this is the tangent given to you, if I ask you draw a parallel tangent to this, so you can only draw only one parallel tangent to this. If I ask you how many pairs of parallel tangents can I draw, it will be infinite. Okay, so ఈ పాయింట్ నుంచి ఇక్కడ ఒక parallel tangent డ్రా చేస్తారు, ఈ పాయింట్ నుంచి ఇంకొక parallel tangent ఇక్కడ నుంచి ఇట్లా డ్రా చేయగలుగుతారు. Okay, so in that way infinite parallel tangents you can get. Okay, but for one tangent you will have only one pair of parallel tangent. For this tangent there is only one pair of parallel tangent, but for the circle there can be infinite parallel tangents. Okay, and in general you can have two parallel tangents. Okay, two pair of parallel tangents to the circle. So we shall do exercise 9.1. So if you have any more confusion also, it will clear that. But before that, let me discuss theorem 9.1 with you. Okay, so what does theorem 9.1 say? Let us do it here itself. So theorem 9.1 says that the radius and the tangent are always perpendicular to each other at the point of contact. Now what is this point of contact? I did not tell you what is point of contact. So do you know what is point of contact? Point of contact is nothing but the point from where, point on the circle from where you are drawing your tangent. Okay, so suppose this is my circle, I am drawing my tangent from this point. This is called point of contact or point of tangency. From where I am drawing the tangent, it is called point of contact or point of tangency. So now let's discuss theorem 9.1. So what is theorem 9.1? Okay, before 9.1, let me tell you three important terms related to tangents. So this point is called, it is called point of tangency, or point of contact. Point of tangency or point of contact. Okay, so this is the tangent. Okay, so now suppose if I take a circle, external point, if I am drawing tangents from the external point, okay, this is what? This is again point of contact, right? And here this is the point of contact, that is the external point P. Now if I measure the length between the point of contact and the external point, if I measure the length or the distance, okay, between the point of contact and the point of external point from where you are drawing the tangent, this is called length of tangent. How many of you understood this? If I am taking the distance between the point of contact and the external point, this length or this distance is called length of tangent. Okay, if I ask you what is the length of tangent, it is actually the distance between the external point and point of contact. And suppose this is the center of the circle. Now if I am joining a line from the center to the external point from where I am having the tangent, so this line is called the line joining the center to the external point. And from external point, how many tangents you have? Two tangents. Clear? So these are the basic points which you will need to know, and let's proceed to exercise 9.1. What does exercise 9.1 say? 9.1 says if I take a radius of a circle, okay, so the radius will be perpendicular to my tangent. So theorem says, I am not writing the entire statement, radius will be perpendicular to whom? Tangent. Where? At the point of contact. This is the theorem 9.1. So understand very clearly. Suppose this is my tangent, this is the point of contact. So if I draw the radius, okay, suppose this is the center O and I am drawing the radius. So I have to prove that they are saying that radius will be perpendicular to tangent. So I have to prove that this angle is 90. What is this angle? The angle between the radius and the tangent at the point of contact is 90. Okay, radius and the tangent at this point of contact should be 90. So to prove this, what do? You just take one more point. Take any other point. Okay, suppose here I am taking a point. Suppose this point is P, I am taking a point Q. Other than point of contact, you take any other point. Are you able to understand my point? This is the point of contact. So leaving this point of contact, take any other point on the tangent. Any other point on the tangent. So now what you do? You just join this center to this point. Okay. So clearly what do you find? OP is the distance between the center and the point of contact on the tangent. OQ is the distance between the center and some other point, any other point on the tangent. So this is OQ. But OP is actually equal to what? It is nothing but the radius of the circle. Center to point on the circle is radius. This distance is radius. So it is radius. So if you see outside the circle, so if I take this point as R, okay, so this OQ I can write it as, this total OQ I can write it as OR plus RQ. OQ I can write it as OR plus RQ. But again look here, OP and OR are same. Why? Can anyone tell me? Because OR is also radius of circle, center to point on the circle. This is also radius. This is also radius. Okay, so from here to here it is radius. From here to here it is radius. So we have learned, that is the reason I told you every point is important. So this is radius and this is also radius. All the radii of the circle are equal. So OP will be equal to OR. So can I write OQ is equals to, instead of OR, can I substitute OP now? Plus I have RQ. Okay, so what is the first step we have done? We have taken a point Q, which is any other point other than our point of contact. Any other point. Leaving this, any other point I can take. Now I have joined O to P and O to Q. OP is nothing but radius I know, and OQ I have. OQ I can actually write it as OR. This R is a point on the circle. OR plus RQ. Now OR is also radius. So instead of OR I have replaced OP. Instead of OR, since OR and OP are same, instead of OR I have written OP here. So clearly see, OP is equals to, okay, OP is equals to, I can write OQ plus OQ minus RQ, taking RQ to the other side. So here itself you can conclude actually in this step, otherwise you can conclude in this step also. So if I take, if this quantity, see there is some quantity, this quantity you get it by adding something to this quantity. Okay, so who is bigger? This is bigger or this is bigger? Suppose say I have 5 is equals to 3 plus 2. Now who is bigger? Adding 2 to 3, then I'll get 5. Means 5 is the bigger quantity. Here also the same thing. So if you are adding something to OP, then only you will get OQ. Means OQ is a bigger quantity. Okay, the same thing I can write 3 is equals to 5 minus 2. This statement is that 3 equal to 5 minus 2. That means if I want to get this quantity, from the bigger quantity I have to subtract something, then I'll get this. So who is bigger? Definitely 5 is bigger than 3. So from OQ I have to subtract, I have to remove something so that I can get OP. So who is bigger? OQ is bigger. Okay. So clearly I can state here that OQ is greater than OP from this statement or from this statement. I hope you understood from the numericals. So OQ is greater than OP. So every point you take any point. So all the points which you see, they will be greater than OP. Okay. So similarly we can prove for all the points. So therefore OP is the shortest distance. Okay, it is the shortest distance from whom? From the center. Shortest distance from center. Are you able to understand this point? So this OP is actually the shortest distance. All other points are at a longer distance. Okay. So you have learnt in your lower classes, the shortest distance is actually the perpendicular distance. How many of you learnt this point? The shortest distance is actually the perpendicular distance. For example, here I have a girl, say Rima. Rima went to Mela, and Rima is, looking at the ice cream shops. There are 3 ice cream shops. 1, 2, 3 ice cream shops. Now Rima wants to purchase the ice cream, but Rima's mother is calling. Rima's mother is calling. Rima, come back soon. So Rima has to purchase the ice cream. Now tell me, where should Rima go to purchase the ice cream? Where should Rima go to purchase the ice cream? In the shorter time, in the very less time, she have to go purchase the ice cream because her mother is calling. Will she go to 1, will she go to 2, or will she go to 3? She will definitely have to go to 2 because 2 is the shortest distance and it is a perpendicular distance. Always remember, your perpendicular distance will be the shortest distance. Okay, so therefore we conclude that OP is perpendicular to tangent. Okay, but what is OP? OP is actually the radius, so the radius is perpendicular to tangent. Clear? So always the shortest distance will be the perpendicular distance. If you consider this as a tangent, okay, this is the circle, actually this is the center, Rima is the center and this is the radius. Okay, and I have considered this point P here. Just compare, this is the point P, this is the point Q. I compare. So I told you that OQ is greater than OP, so OP is a perpendicular distance. So if you don't remember the proof, remember Rima's example. Clear? So let's proceed to exercise 9.1 now. Oh. So this part was not visible. I'm so sorry. So now have a look here. OP is radius and OR is also radius. Now OQ I can write as OR plus RQ. That is what I wrote it here. And OQ is, instead of OR I substituted OP. Okay, because OP and OR are same. Instead of OR I substituted OP plus RQ. Now here I compared. So this explanation is clear, I guess. So from this statement I can see OQ is bigger, because adding something to OP, then only I'll get OQ. Or I have written OP is equals to OQ minus RQ. So either from any of this one statement you can conclude that OP is greater than OQ. Sorry, OQ is greater than OP. Okay. So let's proceed to exercise 9.1 now. So please have a look at exercise 9.1. First is fill in the blanks. Fill in the blanks. A tangent to a circle intersects it at how many points? It will intersect at only 1 point. Secant will intersect at 2 points. Tangent will intersect at only 1 point. Second one, a line intersecting a circle in 2 points is called what? Line intersecting a circle at 2 points is called secant. We have learnt all the definitions, so you have to answer me now. The third question, a circle can have dash parallel tangents at most. How many parallel tangents maximum it can have? It will have only 2 parallel tangents. If I take a circle, so maximum it can have only 2 parallel tangents at a time. Okay, so it will have only 2 parallel tangents. Okay, the next question, a common point of tangent to a circle and the tangent to a circle and the circle is called, the common point between the tangent to a circle and the circle. So to the circle and to the tangent to a circle, what is the common point called? Point of contact or point of tangency. Okay, so any answer will give you marks. We can draw dash tangents to a circle. How many tangents can we draw to the circle? To a circle I can draw infinite points. To a circle I can draw infinite points. Now I will ask you one question. Please answer me now in the chat box. How many tangents can I draw from a point? From a point, okay. How many tangents can I draw from a point on the circle? From a point on the circle, how many tangents can I draw? I can draw only one tangent. Okay, from a point on the circle. If I take a point on the circle, I can draw only one tangent. But if the question is how many tangents can we draw to a given circle, we can draw infinite, because there are infinite points. From infinite points you can draw infinite tangents. Clear? So let's proceed now. A tangent PQ at a point P of a circle. See question number 2. A tangent PQ, there is a tangent PQ at a point P of a circle of radius 5 cm. So you have a tangent PQ and the I'm sorry, the tangent is at a point P and the radius of the circle is 5 cm, meets a line through the center O. Center is O and it is meeting the line at Q. So firstly let's draw the figure. This is a circle. I have a tangent PQ at a point P on a circle. Okay, so point P of a circle. Please have your textbooks with you. So you have a point P on the circle. Okay, I have a tangent PQ. Okay, so let me draw it this way. Right, so this is PQ, the other point will be Q. If this point is P on the circle, the other point will be PQ. So PQ is a tangent touching the circle at a single point, and the center of the circle is given as O. Okay, so I'll read the question again. A tangent PQ at a point P on a circle of radius 5 centimeters. So if I join this radius, so center to this is 5 centimeter, meets a line through the center O. So through the center, if I am drawing a line O, so the line through center O at a point Q, so that OQ is 13. So if I am drawing a line from center O to Q, so OQ is how much? OQ is 13. So now you have to find the length of PQ. PQ is nothing but length of tangent we have learnt. So how do I find PQ? If you clearly see, we have learnt theorem 9.1. Theorem 9.1 says radius and tangent are perpendicular to each other at the point of contact. So now this is actually a right angle triangle OPQ. This is 90, isn't it? This is P, this is O. This is 90. This is given as 5, this is given as 13. What about this? Simple Pythagoras theorem. So can I write OQ square is equals to OP square plus PQ square. Hypotenuse square is equal to sum of the squares of the other two sides. So OQ is given as 13. So 13 square is equals to OP is 5. 5 square plus PQ square. So PQ square is equal to 13 square. Taking 5 square to the other side is minus 5 square. So this is 169 minus 25, or I can get it as 144. Okay, so this is PQ square. Now what is PQ? We know 12 12s are 144. So PQ is 12 centimeters. Because radius, all these are given in centimeters, so this is also centimeter. PQ is nothing but the length of the tangent, so it is 12 centimeters. Have a look at the next question. Draw a circle and two lines parallel to a given line such that one is a tangent and the other is a secant to a circle. So suppose if I have to draw a circle, question number 3, they are asking you to draw a circle. Okay, so this is a circle. So to the circle they are saying that draw a circle and two lines. You have to draw two lines parallel to the given line. Suppose if there is a line given to you, you have to draw two lines parallel to the given line such that one line is a tangent and the other is a secant. Okay, so I have to draw two lines to the circle. Suppose if this is one line which is a tangent to the circle, touching the circle at one point, I have to draw one more line to the circle. This is called secant. It is cutting the circle at 2 points. Okay, so you have to draw two lines which is a secant and a tangent. Okay, and both are parallel to each other. Clear? So next question number 4, calculate the length of tangent from a point 15 centimeter away. So have a look at question number 4. Question 4. Calculate the length of tangent from a point 15 centimeter away from the center of a circle of radius 9. So if I have a circle, this is a point, this is the center, this is the external point. So read the question again. Calculate the length of the tangent. I need to calculate the length of the tangent. So from external point I will get, this is a tangent, isn't it? From external point I'll have a tangent, and for example if this is a tangent, okay, so let's draw it fresh. Right, okay, so it's a circle and from external point I have drawn a tangent. So you have to find the length of the tangent, matlab the distance between the external point and the point of contact. This is the length of tangent I have to find. So what is the information given to us? You need to calculate the length of tangent. from a point 15 centimeter away from the center. So this point is 15 centimeter away from the center. So if I join this, the distance between the external point and the center is 15 centimeter. Okay, so you have to calculate the length of the tangent which is drawn from a point. This is the point which is 15 centimeter away from the center. Okay, so this point is 15 centimeter away, and from this point I am drawing a tangent. So I have to calculate the length of the tangent. And what else is given to you? Radius of circle is 9. So if I join this, radius is 9. Now again, it's very simple. What do we have to do? We know that radius and tangent are perpendicular to each other at the point of contact. So again, this is a right angle triangle. So this is O. Let me take this as point P and Q. So this is P, this is Q, this is 90, right? So this is my hypotenuse, which is 15. OQ is 15. OQ is 15. And radius OP is 9. Okay, I have to find this length of tangent. How do I get? I know OQ square is equals to OP square plus QP square. Hypotenuse square is sum of the squares of the other two sides. Hypotenuse is 15. 15 square is equals to 9 square plus QP square. So QP square, I get it as 15 square minus 9 square, or this is 225 minus 81. So how much are we getting here? QP 225 minus 81. So you get it as 144. So again QP is equals to 12 centimeters. So this is 12. Clear everyone? Okay, so look at the last question. Prove that the tangents at the end points of a diameter are parallel. So the last question is, you have to prove that the tangents at the end points of the diameter are parallel to each other. So this we have, I told you the point but I did not prove it. So now we shall prove it. So chalo. Suppose this is the circle. So this is the diameter passing through center, and two points, this is A and B. Okay, there are 2 points on the circle A and B. So there is a line segment which is joining these 2 points passing through center. So is this the diameter? So I can write AB is what? AB is diameter. Okay, so from end points of the diameter, matlab from this point and from this point, these are the end points of diameter. A and B are the end points of diameter. So from the end points of diameter, I have to draw tangent. This way. Okay, so from end points of diameter, I have to draw tangent. So from A, I will draw one tangent. From B, I am drawing one more tangent. So I have to prove that these two tangents are parallel to each other. How do we prove? So we have learned already. What is this angle, beta? This is 90. Radius and tangent are perpendicular to each other. Now this is the radius, this is the tangent, both are perpendicular to each other at the point of contact. Now please tell me, what is this angle? Radius, OA is radius and this is tangent. Radius and tangent are again perpendicular to each other. Now have a look at these two angles. How are these two angles? Alternate interior angles, isn't it? You have two lines and these two angles are inside the two lines. So interior angles, and they are alternate. One is on this side and one is on the other side. So I can say these are nothing but angle, let me write this as O dash, what shall we take? P dash. Okay, so the angle OB, acha, this is already O, isn't it? Let me write it as Q dash. So angle QBO is equals to angle P dash AO. Or simply, if you want, you can write as angle 1, angle 2. You can write your wish. So then you will write angle 1 is equals to angle 2. So they are what? They are actually alternate interior angles. Okay, so if the alternate interior angles are equal, you have learned in your class 7 and 9 also. If two lines are parallel to each other, if this is the transversal, these are the alternate interior angles. Alternate interior angles are equal when the lines are parallel. But converse of it, the reverse of it, if the two angles, if the alternate interior angles are equal, then I can say these two lines are parallel. How many of you remember the converse also? So if they are parallel lines, alternate interior angles are equal. And if the alternate interior angles are equal, then I can prove that these two lines are parallel, isn't it? So here I got the two angles are equal, which are alternate interior angles. Why alternate interior, beta? I have taken two lines. Okay, these angles are inside the two lines, so interior angles, and these angles are, one angle is this side of this line, other angle is the other side, so alternate side. So they are alternate interior angles and they are equal, so therefore I can prove that q dash is parallel to p dash, both are tangents. Okay, so I can prove this tangent is parallel to this tangent. Okay, so that's all for this class. So we have already discussed how many tangents can we draw from 3 points, 3 cases on the circle, inside the circle, outside the circle, and in next class let's learn about length of tangents. And so there are few 1-2 statements which I'll take it in a different different sessions I'll take, and exercise 9.2 also we shall complete in the next class. Okay, so I hope the session was interesting for you, and I hope there is no doubt at all in this particular topic. So trust me, next topic also I'll clear you in the same way, without any doubt, without any confusion. Okay, so do subscribe to the channel. If you're still watching the video, then definitely like the video right now, and do share it with all your friends, so that if we increase the number, we get more motivation to do more better videos for you. Okay, and also if you want the notes of this particular chapter, you can visit to mathfacilitator.com, the website. You will get the notes of this chapter also completely free. So thanks for watching. Bye bye, take care. Don't forget to subscribe, like and share the class. Take care. Bye bye.